Hey kids, Flexing Teacher Weber here. This is the second video where we're solving one-step equations using addition and subtraction. X plus or minus A equals B. So some unknown number plus or minus another number equals another number. And the way we do these is by isolating the variable. When I say isolate, I mean make by itself. And when I say the variable, I mean like the X or the Y. So when I say the variable, I mean the unknown number, or often just referred to as the unknown, like the X or the Y. So the ones we're going to do today have negative integers in them. So let's take a look at an example. X plus 4 equals negative 4. Well, I want to isolate the X by making it by itself, by making the plus 4 turn into 0. So I subtract 4. And to preserve the equality of this equation, if I do it to one side, I have to do it to the other side. And when I do that, X equals, the signs are the same, so I add them, and I get negative 8. To do a check, I take the original equation, and I substitute in the negative 8 for X. And I ask myself if what I've just written down is true. Is negative 8 plus 4 equal to negative 4? It absolutely is. And if you get the same number on both sides of the equal sign, the equality is preserved, the equation is correct. Let's take a look at another one. N plus 6 equals negative 8. Okay. I want to figure out the value of n by isolating the variable. So to make plus 6 go away, I'll take away 6 from that side of the equal sign, and I'll do it to the other side as well. Plus 6 minus 6 goes away, and I'm left with n equals. So I have negative 8 and negative 6. The signs are the same, so I add them and use my negative. The answer is negative 14. To check it, I use the original equation. Replace the n with negative 14 plus 6 equals negative 8. Is that true? Well, yeah. Negative 14 plus 6 is negative 8. Negative 8 equals negative 8. The equality is preserved. So let's do just a bunch more like this. So this one, y minus 3 equals negative 12. Well, I want to make the variable isolated by itself, so I want minus 3 to go away and turn into 0, and the way I do that is add 3. And if I do it on that side of the equal sign, I have to do it here. When I simplify this, minus 3 plus 3 goes away, and I'm left with y equals negative 12 plus 3. The signs are different this time. And when the integers are different signs, I subtract them. And since I have more negatives, answer is negative. To check it, y minus 3 equals negative 12. Negative 9 minus 3 equals negative 12. Is that true? Well, sure it is. 9 negatives and 3 negatives make negative 12. And if I get both sides the same, then it's correct. Okay, same thing on number 4. I want to make the x by itself, so I want the negative 9 to turn into 0. I do that by adding 9. Minus 9 plus 9 goes away. And then negative 14 and positive 9, the signs are different, so I subtract. And since I have more negatives, the answer is negative. And then if I want to check it, x minus 9 equals negative 14. Replace the x with negative 5 minus 9 equals negative 14. 5 negatives and 9 negatives equals 14 negatives. 14 equals negative 14. Both sides of the equal sign are the same, so my answer is correct. The equality is preserved. Okay, so there's all kinds of little variations, but it's the same idea every time. Check this one out. Okay, negative 12 equals k plus 8. Well, this time the variable is on the other side of the equal sign. But that's okay. I find the variable k. Beside it is positive 8. I want to isolate that variable. I'll do that by subtracting 8. And if I do it to that side of the equal sign, I have to do it over here. Now, as I work down the page, negative 12 and negative 8, signs are the same, so I add them. That's negative 20. On the other side of the equal sign, the plus 8 minus 8 turn into 0, and I'm left with k, which is exactly what I want to get, k by itself. So negative 20 equals k. And if I do that right here, negative 12 equals k plus 8. Substitute in negative 20 for k. And ask yourself if that statement is true. Does negative 20 plus 8 equal negative 12? Sure it does. And since both sides of the equation are the same, our answer of negative 20 was correct. Okay, we'll do another one like that. Again, the variable's on the other side. 14 equals t plus 15. I want to get the t by itself, so I'll take 15 away. And I've got to do it to both sides. 14 take away 15, or 14 positives, negative 15, is negative 1, equals 15 minus 15 goes away, t. And then the check. 14 equals t plus 15. And replace t with your answer. 14 equals negative 1 plus 15. Is that true? Does 14 equal negative 1 plus 15? Sure it does. And if you get equality on both sides of the equal sign, you're good. Okay, just slight differences to some of these questions. 4 plus c equals negative 3. Well, in this case, the variable is c. I want the positive 4 to go away, so I can isolate the c. How do I make 4 go away? Subtract 4. Got to do it to both sides to preserve the equality, to preserve the equal sign. This goes away, and I'm left with a plus c equals negative 3 and negative 4 is negative 7. Now, if I've got a plus c there, I don't really need that plus sign to know it's positive. So I can just take it away. On the other side, or to check it, write down the original equation and replace the c, in this case, with negative 7. And then ask yourself, does 4 plus negative 7 equal negative 3? Sure it does. And if you get that same number on both sides, you're good. C is equal to negative 7. Okay, this one's the same idea, but slightly different. It's the same as the last one, except I want to make the x by itself. Well, how do I make negative 12 go away? I plus 12, and if I do it there, I've got to do it there. Negative 12 plus 12 goes away, and I'm left with a plus x equals 22. But I don't need that plus sign there to know that that variable is positive. So that's x equals 22. And then check my answer, negative 12 plus x equals 10. Negative 12 plus 22 equals 10. And is that true? Sure it is. Negative 12 plus 22 is 10. So since both sides are the same, we are good. Okay, the last couple of questions. Let's get a bit trickier here. Y plus negative 11 equals negative 13. Well, plus negative 11. I want to make the y by itself. Well, how do I make negative 11 turn into 0? Plus 11. And I got to do that on both sides. Well, this goes away, and I'm left with y equals 13 negatives and 11 positives. The signs are different, so I subtract. And the answer is y equals negative 2. To check it, y plus negative 11 equals negative 13. Replace the y with negative 2 plus negative 11 equals negative 13. And is that statement true? Absolutely. 13 negatives equals 13 negatives. Okay, last two. Check this one out. X take away negative 8 equals negative 14. Take away a negative. Well, if you remember from early in the year, we learned about taking away a negative, and we determined that that's the same as adding a positive. So you encounter this situation, it's way easier to just do x plus 8 equals negative 14. Subtracting a negative is the same as adding a positive. And then after you do that, just do your typical strategies for solving an equation. Isolate the variable by subtract 8, subtract 8. That makes 0, and x equals negative 22. And then if I wanted to check it, x minus negative 8 equals negative 14. Well, negative 22, and let's do the plus 8 equals negative 14, and that's absolutely true. Negative 14 equals negative 14. So no matter what the situation, you're always doing the same thing to solve these equations. You find the variable. If it's a plus something, you subtract to isolate the variable. If it's a minus something, you add to isolate the variable. You do the same thing to both sides to preserve equality, and then you can check your answer, and if both sides of the equal sign are the same, then your answer is correct for the variable. I hope that helps. That's all for now. Flexing Teacher Weber, out.